Here's a quick tutorial on how to do some unit conversions. Let's start off with a simple one-step unit conversion problem. How many grams are in 0.235 kilograms? So the first thing we want to look for is the conversion factor. We want to know how grams relates to kilograms. So we can write the conversion factor a number of different ways, and I'm going to show this several different ways. We know that 1,000 grams is equal to 1 kilogram. This is the same thing as saying 10 to the third grams, or 1 times 10 to the third grams, is equal to 1 kilogram. We can also say that 1 gram is equal to 10 to the negative third kilograms. We can also say 1 gram is equal to 0.001 kilograms. So this is part of the reason why students can get a little confused when carrying out unit conversions. There are lots of different ways we can express the relationship between grams and kilograms. It's not crucial for you to immediately be able to draw all of these out, but one of these should stand out in your mind and you should recognize right away. For me, when I'm asked to relate grams to kilograms, right away I know that there are 1,000 grams in 1 kilogram. So that's the conversion factor that I'm going to choose to do this problem. You can do it with any number of these, okay, or any one of these, I should say. All right. Once we've identified the conversion factor in our unit conversion problem, we want to make sure that we know or identify the known and the unknown in the problem. Now really we've already done this, right? We know we're going back and forth between grams and kilograms. So, the known and the unknown. What we can do is underline the known and the unknown in the question over here. So the grams, that's our unknown. We want to know how many grams there are in 0.235 kilograms. This is our known. So I need to relate 0.235 kilograms to grams. Okay. So our unknown and our known. Okay. Once we've identified our known and unknown, we'll relate them to the conversion factor and then solve for the unknown. Now there are several different ways we can do this, and I'm going to show you each way. The first way is to set this up as a mathematical equation. In an equation, there's an equal sign, right? There has to be. So what we're going to do is I'm going to choose the left-hand side to relate our unknown and our known. Our unknown, I'm going to call our unknown x. X refers to the number of grams. Our known is that we have 0.235 kilograms. So here are unknown and our known. We need to relate this to the conversion factor. The units of our conversion factor have to match up with the left-hand side of this this mathematical equation, okay? So remember that x is our unknown in grams. So that means if grams is in the numerator here, it has to be related to the numerator over here, okay? Whereas kilograms in the denominator, we need kilograms over here. So I've put in my units, and now I just have to fill in my conversion factor from over here. There are 1,000 grams in 1 kilogram. So I know the 1,000 grams goes in the numerator. And the 1 kilogram is in the denominator. Again, when you set this up as an equation, the units have to match up. Grams to grams, both in the numerator. Kilograms to kilograms, both in the denominator. Now we're ready to solve for our unknown x. To do that, we have to isolate it or get it alone. So what we need to remove is this 0.235 kilograms. So to do that, I'm going to multiply both sides by 0.235 kilograms. And by doing this, we're going to cancel out the 0.235 kilograms on the left-hand side of the equation, and it gets moved to the right-hand side of the equation. So now let me rewrite this. We see that x is equal to, what do we have over here? We've got the 0.235 kilograms, okay, multiplied by, I'll just use an x for multiplied, 1,000 grams divided by 1 kilogram. And here we can see that our units of kilograms cancel one another, and we're left with units of grams. So we're going to take 1,000 times 0.235. So all we're doing is, when we're multiplying this number by 1,000, we're just moving the decimal place over 3 times to the right. And now we have our answer. We've solved for x, which is the number of grams in 0.235 kilograms. So this is one way that we can solve this problem. Now, students often like to use something called unit analysis or dimensional analysis. So let's take a look at how unit analysis differs from how we've set up this problem as a mathematical equation. I'm going to go ahead and leave this here so we can compare it to how we solve the problem using dimensional analysis. In dimensional analysis, we're going to start off with our known. I'm going to start off and write that on the left-hand side. There's our known. And using dimensional analysis, I'm going to be multiplying by a conversion factor. And when I multiply by the conversion factor, I want to do this in such a way so that I come up with my desired units. The desired units here are grams. So if I'm multiplying kilograms by a conversion factor and I want my answer to eventually be in grams, that means grams needs to be in the numerator, and what I want to get rid of, the kilograms, needs to be in the denominator. I know that there are 1,000 grams in 1 kilogram. So then we can see here that the kilograms are all set up to cancel one another out, and we're left with units of grams. So we get the same answer we did before. When doing dimensional analysis, we are cutting out the equation. So you don't see, when we set this up, we don't have an equal sign. Okay, we're multiplying here. But this looks just like what we have over here. So you see, you end up with the same answer. It's really just a question of which method you feel most comfortable in setting up. Most of the time we recommend that students first learn how to solve problems using or coming up with a mathematical equation and solving for x. Once you become comfortable with this, you'll find it easy to set up the problem just using dimensional analysis. In the next problem, we'll try to do a multi-step unit conversion using both methods so that you can see how they differ from one another.